Hello and welcome to Whiteboard Science, the series where we give you a quick rundown of a scientific topic to enhance your scientific knowledge. My name is Ray, and today we're going to talk about Hot-Start PCR. So far, we know about PCR and how it works in its most standard form: the denaturation, the annealing, all that fun stuff. Surely it can't be more complicated than that, right? Well, when the denaturation stage requires a temperature of 94 degrees Celsius, and most DNA polymerases work at temperatures around 68 to 72 degrees Celsius, you can start to see where things get a little complicated. This initial raising of the temperature can potentially lead to something called non-specific amplification. Or, put simply, amplifying a portion of DNA that is not the target. Since our sample must pass 72 degrees Celsius to make PCR work, greater minds have already come up with a solution. The solution being Hot-Start PCR. Hot-Start PCR is a variant of polymerase chain reaction, developed to suppress temperature-induced activity, at least until the first denaturation step where the temperature is raised. Remember those dNTPs? Well, with Hot-Start PCR, we use modified dNTPs, allowing for setup at room temperature without the potential complications. Some common modifiers include chemical, antibody, or even aptamer-based mechanisms. So, overall, you still need the primers and the dNTPs that make standard PCR possible, but only now with a dash of hot-start DNA polymerase. Hence, hot-start PCR. Now, even if you got 99 problems, at least amplification ain't one. When PCR reagents need to provide consistent and specific high-yield amplification for your DNA, Hot-Start PCR offers benefits such as an increase in target yield and enhanced sensitivity. So if you are looking to explore some of the hottest Hot-Start PCR methods, check out our PCR eBook, or feel free to reach out to explore which solutions are right for you and your research. Beyond that, we'll see you next time on Whiteboard Science.